Hi guys, so good morning. Today we're going to be learning some more properties of exponents. So you should have learned some of them on Friday. Please take notes just like you normally would. Write down the rules, the properties, and the examples that we do. Today we're doing properties of exponents, negative exponents, and power rule. So we're just going to kind of build on what we learned last time. So let's go ahead and get started here. So the first two slides are just review from what you learned on Friday. So if I want to multiply together two things that have exponents, they have the same base. So the base is a, the exponent is m and n. I just go ahead and add those exponents together. So it equals a to the m plus n. The other one that you learned is called the quotient rule. So we're dividing powers. So if I have the same base raised to an exponent over the same base raised to an exponent, that's going to be equal to a to the m minus n. So just take the top exponent and subtract the bottom exponent, and that's what it's going to be equal to. So some new rules that we're looking at today, one of them is called the power rule for exponents. So we're taking the power of a power. So notice here a is raised to the m power, and then m is raised to the n power. So if I have that where an exponent is raised to another exponent, that's going to equal a to the m times n here. Okay, so let's look at why that is. So if I have, let's say, x to the second power, and then I raise that again to the third power, let's write out what that means. That means here that x squared is the base, and I'm raising it to the third, which means I need to multiply this base x squared times itself 3 times. So this would be x squared times x squared times x squared. So that is 6 x's being multiplied together. So now we would go back to our product rule here. If I'm multiplying things with the same base, I have to add their exponents together. So this would be x to the 6th power. So the other a couple new ones that we're going to learn today, if I can get this slide to show up here, is if I have a product, meaning the stuff inside the parentheses is being multiplied together, and I raise it to a power, then each thing inside the parentheses will be raised to the power of m here. Having a really hard time getting my slide to advance here. Let's see if we... So it just means everything inside the parentheses needs to be raised to the power of m. Okay. One of the biggest mistakes that we had on the test is if I have something like this, notice here, these are not a product, right? Those are added together. If I have a plus b squared, that equals a plus b times a plus b, which means I have to multiply 4 different things together, right? So on the test, this was missed a lot. If we saw ab squared, we just squared a and squared b. Notice this is different here because these are multiplied together. If the things inside the parentheses are multiplied together, then everything in there can just be raised to the m power. If they're added together, we can't just square both terms here. We actually have to write them side by side, and we have to distribute a to both and then b to both. So just notice the difference there at the same time, okay? All right, let's go ahead and look at our next law of exponents. We have the power of a quotient, which is basically the same thing, but now if I have a quotient here inside the parentheses instead of a product, remember quotient means divide, product means multiply. If I have a quotient in there and I have everything raised to the n power, then still everything inside the parentheses is going to get raised to the power of n. So this would equal a to the n over b to the n. All right, so negative exponents. Sometimes we get negative exponents, and that's because of our quotient rule where we have, like, if I had a to the 5th over a to the 3rd, I would simplify this by taking 5 and subtracting 3. This would be a squared. If I were to flip that over and I would have said a to the 3rd over a to the 5th, then when I take my top exponent and subtract the bottom exponent, I'm going to get a negative number. It's going to be a to the negative 2 power. So we can see that what that means is that I had the 3 a's on the top On the bottom, I would have 5. So those 2 would cancel, those 2 and those 2. Those all become 1s, and my a's are left on the bottom. So we can see if I have a negative exponent, what that means is that these a's belong on the other part of the fraction. Right now, if it's just a squared, a to the negative 2, that would be like a to the negative 2 over 1. So that just needs to be flipped in order to make that positive. It's like this is a little flag that says this one's offsides, this one is not on the right part of the fraction. So if I have a negative exponent, it means I need to change it to the opposite part of the fraction. So a to the negative n over 1 becomes 1 over a to the n. And notice when it flipped to the right side and became correct and it's on the right part, then the negative is gone. So I would take the negative away once I change it. It'll be the same thing if it's on the bottom. So if I had 2 over a to the negative third power, for example, it means this a to the third is on the wrong part of the fraction. It needs to be moved up. 2 is already up there and it has no negative exponent. So 2 would still have to be on the top, but I would have to bring up a to the third. So there would be nothing left on the bottom except a 1. And if I'm dividing by 1, I don't need to write that. Okay. So let's take a look and see if we have any other rules here. I'm not quite remembering. If I can get my slide to advance, it's being stubborn. Oh yes, the power of 0. So anything raised to the power of 0 is always equal to 1. So it doesn't matter what it is, if it's all raised to the power of 0 is equal to 1. And why is it 1? Well, it's because if I take anything and divide it by itself, that gives me 1, right? And x to the 0 represents that. It represents something being divided by itself, because if I were to use the quotient rule here, I would take the top exponent and I would subtract the bottom exponent, and 1 minus 1 is 0. So it would be the same thing if I had like y to the 5th over y to the 5th. Because I'm just dividing the same number by the same number, that's equal to 1. But if I were to use the quotient rule, I would take this, it would be y to the 5 minus 5, which is equal to y to the 0. So anytime you see y to the 0 or x to the 0 or anything raised to the 0 power, it just means we're dividing the same number by the same number. And so it will equal 1. All right, so let's do some examples here where we use these rules. When we're using one rule at a time, it doesn't seem too complicated. When we start adding rules together, it gets a little bit confusing. So let's go ahead and do some examples. So the first thing I would do in a problem like this is I would think about those negatives. If I have negative exponents, that means these are kind of offsides. They're on the wrong part of the fraction. Excuse me. So the first thing I'm going to do is I'm going to take those and put them on the right part of the fraction. So everything else, everything that does not have a negative exponent. So 2 doesn't have a negative exponent. 2's exponent here would be 1. It's 2 to the first power times h to the third power times j to the negative third power times k to the fourth. Just remember that the exponent on something is only right next to it. It's only on the variable or the number right next to it, unless you see parentheses. So like this 2 right here is only raised to the first power. It's not raised to the third power. That's the mistake students make a lot of times, is they decide that the coefficient must also be raised to that power, which is just not true. Unless you see parentheses around it like that, then it would be raised to that exponent as well. But because there's no parentheses here, the 2 is separate from the h to the third when it comes to the exponent. All right, so let's go ahead and continue. So I have 2 times h to the third. This j to the negative third, it's on the wrong side of the fraction. So I need to move j to the third down. When I move it down, I'm going to get rid of the negative because now it's in the right place. And then k to the fourth is still on the top. On the bottom, I have the 3. I have the j, it's still down here. And k is raised to the negative second power, so k needs to be moved up to the top. So now everything has a positive exponent. Everything's in the right place. Now I can continue simplifying. So I'm going to actually ignore the denominator for now, and I'm just looking at the numerator. K to the fourth times k squared, that's just the product rule there. So I can go ahead and combine those with one base of k and just add their exponents together. 4 plus 2 is 6. On the bottom now, I have j to the third times j. So because they have the same base, again, I can add their exponents. If I don't see an exponent, remember it's a 1. So this would be j to the 4th. Now the numbers 2 over 3, those won't reduce at all. So I will just leave that as 2 over 3. And now I have h all with one exponent, k with one exponent, and j with one exponent. So there's nothing else I can do to simplify here. So that would be my result. Okay, so let's try another example. So I have r squared over 2r to the negative third times r to the 0 power. So the first thing I need to do here is take care of my negative exponent. So because I see that there's r to the negative third down here, I know that I'm going to have an r to the positive third on top. So that's going to take care of that. Whoops, I crossed out the 2, but I surely shouldn't have. So I would be left with r squared times r to the third on the top, and 2 and r to the 0 on the bottom. Okay, so now remember that r to the 0 is equal to 1. So I can actually just cross that out. It's just like timesing 2 by 1. It's just 2 times 1. On the top, I have r squared times r to the third. Again, I can add those exponents together because I have the same base times the same base here. So that'd be r to the 5th power. And then on the bottom, I just have 2. So that would be the simplified version. All right, let's try a couple more examples. I have 4x to the third over 2x negative 2 times 2x to the negative 2. Here, I'm going to take my 2 and my 2 here, and I'm going to multiply them together. So I have 4x to the third. Whoops, I shouldn't write up there because my other example is going to be over there. So I have 4x to the third on the top, just leaving it the same. Down here I have 2 times 2, which is 4. And then I have x to the negative 2 and x to the negative 2 times each other. That'd be x to the negative 4 if I add negative 2 plus negative 2. But this part's on the wrong part of the fraction. It needs to move up to the top. Okay. Here the 4 is going to cancel with the 4. That's going to become a 1. So really I just have x to the third times x to the 4th, which equals x to the 7th. Okay, so let's try this next example. Hopefully I didn't cover it up with my scribbles here. Oh, it's being stubborn. Okay. So I have 3a to the negative third b squared. Let me just get my eraser here and take care of that. And so the first thing again I'm going to do here is I'm going to move everything that has a negative exponent back to the proper side. So I've got this a to the negative third. So the 3 and the b squared have to stay up top, but that a to the negative third is going to move down here to the bottom. I have a to the 0, which I can just cancel out because that's just a 1. So it's just like 4 times b times 1. So I'm going to keep everything down here that I already had, 4b, a to the third, and b squared. But then that a to the third is also going to move down here. So now I'm going to ignore the top for a minute, and I'm just going to simplify what's in the denominator. So on the top, I have the 3b squared. On the bottom, 4. And then b times b squared would be b to the third. Remember, if I have no exponent, it would be a 1. A to the third and a to the third would make a to the 6th. And then because I have b squared over b to the third, I would take the top exponent and subtract the bottom, which would give me b to the negative 1. It always lands on the top. But because it's a negative 1, I know there's going to be a b on the bottom. The other option is to think, well, I have 2 b's here and 3 b here, 3 b's here. 2 of them will cancel out, so 1 b will be left on the bottom. I have to move that b to the first power down. So on the top, I'm only left with 3. On the bottom, I have 4, a to the 6th, b. And that would be my simplified form. As long as you only have one a within here, one b, you only want one copy of the variable with whatever exponent it needs. Your numbers need to be simplified as much as possible, but 3/4 won't simplify, so that's simplified. All right, so here we have basically everything except for this 3 is in the wrong place. So I'm basically just going to flip the fraction over, except for the 3, it will stay on the bottom, but everything else will trade places. So x to the 4th and y to the 3rd belong on the top. X belongs on the top. It's just to the first power, so I don't need to write that. And y to the 3rd. Then here we have x to the 3rd, y to the 3rd that will be down here with 3. So everything just traded places. Everything that was on the bottom went to the top. Everything that was on the top went to the bottom. I'm going to ignore the bottom for a moment because I have more than one base x and more than one base y on the top. So that would be x to the fourth times x to the first is x to the fifth. Y to the third times y to the third is y to the sixth. And then on the bottom, I've got the 3x to the third, y to the third. So now if I have 5 x's on top and 3 on the bottom, I know there are going to be x squared. There's going to be 2 x's on the top. If I have y to the 6th over y to the third, that's y times itself 6 times and y times itself 3 times. 3 of them will cancel out. 3 will be left. Since the bigger number was on the top, they'll be left on the top. The only thing left on the bottom is the 3. So let's try another one. So notice here that we have our parentheses and everything is raised to the power of -1. So that means -2 is going to be raised to the power of -1. X squared is raised to -1, and 2 times -1 is -2. And y is raised to the 4th power, and 4 times -1 is -4. So this means basically everything belongs on the bottom. -2, x squared, y to the 4th. All of them belong down here. Because that was a -1, it's just going to be -2 to the 1st power. And there's really nothing else I can do here to simplify. But when you're simplifying, you should never have negative exponents left in your answer. So just move them up or down depending on if they're on the bottom or the top. All right, so let's look at a couple more examples here. Here we have our parentheses. If you have parentheses within here, you always want to kind of do what's there first. So let's go ahead and do that. So everything here is being raised to the 2nd power on the top only. So this would be 2 squared times x to the -4 squared. If I already have an exponent, remember, multiply those. That'd be x to the -8th. On the bottom, I have 2x to the 3rd, and then I have a -x to the 0 power. That's just going to become a 1. Actually, because x to the 0 is 1, and then there's a negative in front of it, that's actually going to be a -1. That's going to make that negative. So here I have 4x to the 8th over -2x to the 3rd. The 4 over 2, that's going to reduce. It's going to become a -2 on the top. X to the 8th over x to the 3rd. 8 minus 3 is 5, so that'd be x to the 5th. The only thing left on the bottom is a 1, so it would just be -2x to the 5th power. Okay, here we have everything in the entire thing is raised to the 4th power. Again, we have a to the 0, b to the 0, so those would be 1 times 1, which leaves a negative times negative, which is going to make the bottom a positive b. On top, I have -ab squared, and everything is raised to the 4th power. Here I have a choice. I can either raise everything to the 4th power first, or I can simplify what's in the parentheses first and then raise to the 4th power. It really doesn't matter which order I do it in. I'm going to go ahead and simplify inside first. So b squared over b, 2 minus 1 is just b, so the squared would cancel with that b on the bottom. So I have -ab to the 4th power, so -a to the 4th times b to the 4th. All right, so that's it for today, guys. So give those examples a try. If you have any questions, please don't hesitate to email me. I can answer emails all day. And also, if you need a little more help, we can always set up a Zoom call. So just let me know how you're feeling about this, and have a great day, guys.